Yeah, I want to get round to covering something which we didn't quite do last lesson. All right? So, we looked at differentiating functions of this type. Okay, so d dx of e to the x. What's that equal to?
Ex.
Yeah, good, e to the x. Just by definition, okay? The derivative of a logarithm function should be proportional to its size, okay? In this case, if you take the derivative of e to the x, so e, 2.718, you should just get exactly the same thing back again, okay? So it's not just proportional, it's actually equal to. But what if I change this? Because we didn't look at this, okay? What if I change this to a different base? So instead of 2.718, etc., 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 what if I had 2 to the power of x? How do I differentiate that? So you remember, if I differentiate something of this type, it should be proportional to 2 to the power of x. That's my definition of an exponential. The rate of change should be proportional to its size. The bigger something is, the faster it can grow. If I wanted to write this as an equation, it's going to be some constant multiplied by 2 to the power of x. That's literally what this means. My question is, what is that constant? How can I work that constant out from this? Any ideas? Well, if it's 1, that's 1 there. Okay, so in this case, the constant is 1. Okay, so it can't be 1. It's got to be something other than 1. Does anybody know how we can work that out?
According to the notes, you need to use log.
Good. So I need to understand this fundamental idea of logarithms. Okay. So let's have a look. Okay. I'm just going to let this thing equal y. So y is equal to 2 to the power of x. Okay. Now what I'm going to do is take the logarithms at both sides. I'm starting to see powers going on, so I'm going to take logarithms at both sides. And just for argument's sake, because I know how to differentiate and deal with logarithms which are to the base e, I'm going to take the natural log of both sides. In other words, the log of base e of both sides. Is that okay? So I'm just simply taking the log to the base e of both sides, the natural log. Okay. Well, okay, if I rewrite this, I get natural log of y should be equal to, well look, you know your laws of logs, right? I can bring this power down and multiply it out the front. So x times by the natural log of 2. Happy with that? Yeah, happy with that? Okay. Well, I guess I want y. Okay, I want y. So why not write y as, well, back in exponential format, this base is e. Okay? So it's going to be e, and that's the power. That's literally what a logarithm means. Okay? My base is e, and that is my power. So it's going to be e to that power. E ln 2. Okay? So in other words, what I'm saying, remember y originally was 2 to the power of x. Y originally was 2 to the power of x. So in other words, 2 to the power of x can literally be rewritten as e to the power of natural log of 2 of times x. Okay? Now if I come to differentiate this thing, so if I want to find the derivative of this thing, which was my original question, okay, would you be happy now? This is just a chain rule. Okay? It's going to be, well, differentiating e to the power of something is e to the power of something, and then multiplied by the derivative of the inside function. What's the derivative of x ln 2? Ln 2, perfect. Does that make sense? Yeah, good. And again, this thing here, well, e to the power of ln 2 is just 2. So I could rewrite this, if I like, as natural log of 2 times by 2 to the power of x. Make sense? Yeah? So in other words, when I came up here, okay, I knew, let me get rid of this, okay, I knew that the derivative of 2 to the power of x is going to be some constant times 2 to the power of x. This is what I have down here. So in other words, I know that that is going to be equal to ln 2 times by 2 to the power of x. Okay? So there's my 2 to the power of x, and my constant, which I originally predicted, is just the natural log of 2. Make sense? Yeah? Good. So it comes from understanding the idea that 2 to the power of x can be written as e to the power of a natural log of 2 times x. Okay? Or if I wanted to write 3 to the power of x, that would be e to the natural log of 3 times x. Yeah? Or if I wanted to write 1,000 to the power of x, it would be e to the natural log of 1,000 times x. All good? Fantastic.